Okay, good morning. Let's go ahead and get started. We have a lot of work today. At least I do. And so I have Eduardo with me today, the TA. So he's going to help me teach the course today. I'm going back to Systems Engineering Tools, which is topic number 6. I'm going to skip IDEF methods. I'll give you an overview next week. Today I want to introduce UML, Unified Modeling Language. And then we're going to do some examples on the computer with IBM Rational Software Modeler. And Eduardo is going to help us through some simple examples of how to construct UML diagrams using the software. Okay? So what I'm going to start with is I'm just going to go through some slides which I uploaded on e-learning and describe the different types of UML diagrams that you need to know. So I have about 40 minutes to go over these, and then Eduardo is going to stop me. Whether I finish or I don't finish, he's going to stop me, and then he's going to go over the examples. Okay? So we are shifting the focus now to you working on your projects. So most of next week, you're going to be working on your projects. Tuesday, we're going to have a lecture, and then Thursday, we won't have lecture because Eduardo and I are going to be out of town. We're going to be presenting at a conference in Orlando. So that day, Thursday, you can meet with your team and work on your project. So I'll remind you on Tuesday next week. Okay? So from here on, I suggest you concentrate on your project. And so let's go over the UML, because you're going to need this to create your diagrams. So UML is a language for visualizing, specifying, constructing, and documenting the artifacts of software-intensive systems. Okay? So UML was designed for software development, software engineering. And then a few years back, the systems engineering community started adopting UML in trying to portray different aspects of a system to be designed or an existing system. The traditional tools we use for representing systems is IDEF methods, and I'll do an overview next week. But I usually don't cover IDEF methods because we have another course which focuses on systems engineering tools. And so IDEF methods are taught in detail in that course by Professor Richard Meyer. Okay? So here we're just going to glance through some UML documents, and we're going to just use those for representation. But in general, UML diagrams are very useful for software development. So UML is a standardized specification language for object-oriented modeling. And it's a general purpose modeling language with graphical notation used to create an abstract model of a system. And it's officially defined by the Object Management Group. And so UML is a standard. Okay? So any company that's producing object-oriented software, they're going to use UML. And some of the systems engineering projects actually also use UML. And that's why I'm surprised every semester that our students, for the most part, have not been exposed to UML. UML is something we need you need to at least be aware of and know how to use it. So UML basically is going to be a representation through diagrams. And so let's talk about things in the UML diagrams. They are going to be structural things and behavioral things. So structural things are going to be those things that are mostly static parts of a model. And then for structural things, we have different diagrams that we're going to use. And for example, we can represent a class. Again, in object-oriented modeling, when we model a system, we think about a system comprised of objects. And these objects have attributes. And they have functions or methods or actions that they can perform. And they can change the attributes. Okay? And so we can have classifiers such as class, an interface, collaboration, use case, active class, component, artifact, node. And for behavioral things, we're going to represent dynamic aspects of a system. Remember the interaction, the sequence diagram? The sequence diagram shows some behavior, some interaction. They are state transition diagrams or state machine charts. They are going to represent some kind of behavior of the system or subsystem or component. Also, we can have activity diagrams, which shows the activity of what can actually happen under different scenarios. Okay? So those are the things in the unified modeling language. And in UML, we group things. And when we group things, we usually call this a package. And this is something you'll find in object-oriented software or languages such as C++ or Java. You can have several subsystems. You group them together to create a system. Then that system, we can call it a package. Okay? We can also add comments to UML documents. So Eduardo may show us how to do that. And so any diagram that you're going to draw, you may have to add notes to describe whatever entities you have in your diagram. So in UML documents, we show relationships between objects or entities by using digraphs. They can be unassigned digraphs like this one, or they can be assigned digraphs like this one and this one. When we have a digraph, which is a dashed arrow like this one, it represents a relationship between two things in which a change to one thing, which is the independent thing, may affect the other thing, which is the dependent thing. So the dependent thing is going to be on the right side of the arrow. Okay? So dependency is going to be represented using this type of digraph. And you can have an association between two entities. If there's an association, then we're going to represent the association using a line, a solid line. So this is going to represent a structural relationship that describes a set of links between the entities. There's this concept of generalization in object-oriented analysis. And generalization shows a relationship in which the specialized element, which is usually the child, builds on the specification of the generalized element, which is the parent. Okay? So in object-oriented analysis, for example, we can think about animals. Okay? Animals can be a group or a class. Okay? Within that group of animals, I can create a generalization or specialization. So within animals, I can have mammals. Okay? So animals can have certain attributes and behaviors. And when I go down the hierarchy to mammals, the mammals can also inherit some of the attributes of the animals. From mammals, I can choose a particular animal that I like. For example, elephant. The elephant, again, I'm doing generalization. The elephant can also inherit the behavior of mammals and also the behavior of animals. Okay? So I'm going to talk more about this a little bit later. So to represent that kind of generalization, we're going to use this type of diagram. Okay, so relationships. And the actual UML diagrams, the current version of UML, I don't know if it has changed yet, do you know? Yeah, according to 2.0, there are 13 different types of diagrams. Okay, and the following picture provides a way of categorizing them in some kind of hierarchy. So, so the 13 different diagrams, there may be more diagrams now, but these are the basic ones. So let's start with the left side here. So we can have structural diagrams and behavior diagrams. Okay. So structural diagrams are the diagrams we're going to use in our design models. We are also going to use behavior diagrams. So an example of a structure diagram is a class diagram. Okay, last time I mentioned that a class is going to represent an object in your system. A class is an instance of an object in your system. Okay. For example, traffic light. In the traffic light example, I showed you a use case diagram where we had farm road lights. Okay, that's an object. We can create an instance of that object using a class diagram. Okay. Other structural diagrams in UML, component diagram shows the different components of your system. Object diagram shows the objects within a system. And we can also have these other diagrams, such as the deployment diagram, which basically shows the system in its environment. When you deploy your system, what is it going to interact with? And so on and so forth. For the behavior diagrams, we have activity diagram, which is going to show the activities between entities. Use case diagram, which is going to show the use cases or functions of a particular aspect of your system. Then we have a state machine diagram, which is going to basically show the state transition diagram. And we also have an interaction diagram, which shows how the different entities interact, or what entities actually interact. Do you remember the n-squared chart? The n-squared chart is a type of an interaction diagram. Okay? It shows you the interchanges between entities. Then under interaction diagrams, we have these special cases. See, this is a generalization. So a sequence diagram is a type of interaction diagram, and we're going to focus on that. We can also have an interaction overview diagram. We can have communication diagram, which focuses on the aspects of communication between the entities in your system. Timing diagram, some of you may have seen these diagrams before. The ones that Eduardo highlighted are the ones that we're going to focus on the most. Okay? But I encourage you to go online and read on each type of diagram, find out what it represents. Because UML diagrams are just going to represent, each diagram is going to represent a particular aspect of your system. So in order to have a complete design model, you need to have a series of these diagrams. Okay? And the same thing is going to hold for IDEF methods. The different IDEF methods, integration definition method for systems, and each one is going to show a particular aspect or perspective of your system. Okay? So to have a complete design model, you're going to have a whole bunch of different diagrams, okay, or IDF methods. So let's go over in detail the class diagrams, the use case diagrams, the sequence diagrams. We're going to, I believe, start with the class diagrams. The class diagrams are going to describe the static structure of the system. It's going to include the objects in your system, the attributes of each object or entity, and the associations that object has. The use case diagrams are going to describe the functional behavior of the system as seen by the user. Okay, and we need use case diagrams to actually discover what the system is going to do or should do, the functions. And from there we can derive the requirements. Sequence diagrams. Sequence diagrams are going to describe the dynamic behavior between actors and the system and between objects of the system. State chart diagrams, again, these are state transition diagrams, which you've already done by hand. But now we're going to start using the software. They will describe the dynamic behavior of an individual object as a finite state machine. Okay? Finite state machine simply means you're going to have a finite number of states. Okay? Remember, in the systems modeling theory, this is not a requirement. We can have an infinite number of states. But as for representation for UML diagrams, we need to have a finite number of states. The activity diagrams are going to model the dynamic behavior of a system. Activity diagrams in particular show the workflow. It's more like the flow chart of how information is going to flow, or how activity is going to flow through a system. Okay? And so let's start with structure diagrams, class diagrams. So I'll show you some examples. So to construct a class diagram, we need to understand the following. Okay? Again, these are concepts in software engineering because UML was designed for building software. And so for any given class, we need to have type. Okay? So this is an abstraction in the context of programming languages. For example, we're going to have name, which could be, for example, integer, then the purpose, maybe integral number, and then the members of that type. In this case, we have 0, 1, 2, 3. And then we can also have an instance. An instance can be a member of a specific type. The type of variable represents all possible instances the variable can take. So if you remember in your programming language, you can have a type int or type double. And when you have an instance, it's basically having a realization of that particular type. Okay? So with classes, a class is basically an abstraction in the context of object-oriented language. It's an abstraction of an object. Okay? So therefore, a class is going to encapsulate both the state variables and the behavior, which are the methods of the system. So if you think about a class, it's going to encapsulate the state, okay? The state of that particular object, which we can call them the attributes, and then the methods or functions that that object can actually perform, which is going to basically describe the behavior of that object. Okay, so that's going to be a class. So here's an example of a class diagram. In this case, I have a class called bank account. Okay, so I have to have a name for a class, Any class that you create must have a name. It's going to represent a particular object in your system. So to represent a bank account, I need to have a class called bank account. Then each class is also going to have attributes. In this example, if I have a bank account, maybe I need also to have the owner, okay, which is going to be a string, the name, who owns this account, this bank account. And then I need to maybe have a balance, how much money is in the bank account, which is going to be in units of dollars. So these are attributes. And then we also need to have operations, which we call methods in object-oriented language. You can call them functions. So each class is going to have operations or methods. For example, a bank account can have a method called deposit, which is going to take in some amount, which is dollars. So if you want to deposit some amount in your bank account, you need to call this method. This method knows how to do it, how to do the deposit. Similarly, you can also withdraw from this bank account. So there's a method called withdraw, and you specify the amount. Okay. So a class is going to have the name, then it's going to have the attributes, and then the operations in that order. Okay. So a class, in essence, is an abstraction of a concept within a computer program. And like I just mentioned earlier, it's going to encapsulate the state and the behavior. The state is going to be the attributes right here, and then the behavior is going to be described by the operations. Okay? So the class name is the only mandatory information. You may have a class, but it may not have attributes and operations. But it has to have a name. Any questions on class diagrams? Again, when I'm describing these things, I want you to think in terms of systems. Okay, so you can actually see where we're going with this, right? We can represent a particular component using a class diagram, right? A component can have the state, the attributes, and it can also have the functions. Okay, the next state function, the output function. Remember those? Okay, so we can actually use a class diagram to do that. Okay, so we need now to talk about relationships in class diagrams. Okay, and so here's an example. We're going to denote different types of relationships. If we have a system, we're going to have different components of a system or subsystems that are going to interact. And so their interaction is going to be represented by via associations in UML. So here's an example of an association we have here, which is this solid line. This is an association between a class called flight and another class called frequent flyer. Okay, so this flight class has the different attributes, which are flight number, departure time, and flight duration. And then the methods or functions for this class are delay flight, get arrival time. These are the methods that this class can perform. And then this class is associated with frequent flyer, which should have a name, a first name, last name, and then frequent flyer number. Okay, so when we talk about different relationships, these relationships are going to allow us to see what kind of association is between the two entities. For example, the type of associations are going to be indicated by the different numbers. So here I have 0. There's a number here. If you can see that, there's a 0, dot, dot, and a star. And over here, there's a 0, dot, dot, and the star. So the meaning of the numbers you're going to put by the association representation are as follows. If you have a 0, then dot, dot, 1, it means that you can have 0 or 1 of that particular entity or class. If you have a number 1, it means that you can only have 1. Okay? That association should only have 1. If you have 0, dot, dot, it means you can have 0 or more. So in this case, if you have a flight, you can have more than 1. You can have 0. Okay. As far as the frequent flyer, you can have again more than 0 or 0 associated with each flight. Okay. And then if you have 1 or more, it's going to be represented as 1, dot, dot, and a star, meaning 1 or more. If you have exactly n, then you can have n, where n has to be greater than 1. If you have 0 to n, then you have 0, dot, dot, n. If you have 1 to n, then you're going to have 1, dot, dot, and n. So this is going to allow us to see the multiplicity in terms of these associations. Okay. Here's another example of a one-to-one association. Country is a class, and it has an attribute of name. So a country can have a name. Okay. And then a country can also have a city. In this case, it's a capital city. So if a country has a capital city, then for any given country, this has to be a one-to-one association. In other words, each country must have one capital city, no more than one. So you represent that association one-to-one. Okay. Another example, I have a class called polygon. So this class can represent a polygon, and it has a method called draw, meaning I can draw a polygon. Okay. So a polygon has an association with a class called point. Okay. So if I'm going to draw a polygon, then that polygon is going to be associated with points. In this case, for a given polygon, which is 1, I can have several points. In this case, it shows n. One-to-many is an example of one-to-many association. That is, for a given polygon, for a given one polygon, I have to have n number of points. These points are going to be the x, y coordinates, which are going to have a type of integer. Okay? So that gives an example of this 1 to n relationship. Okay? So where n has to be strictly greater than 1, remember? So if you're going to have a polygon, then you have to have more than 1 point to represent that polygon. Another type of relationship in class diagrams is what we call aggregation. Aggregation is going to be represented using this diamond shape. Okay? Aggregation means consists of. For example, an exhaust system of an automobile consists of a muffler and a tailpipe. Okay, so this consists of is represented as this diamond shape here. So this is an aggregation. So this exhaust system comprises a muffler and a tailpipe. Okay. So if you have a system class, your system is going to consist of different subsystems. So you can represent it using this type of relationship, which is an aggregation relationship. Okay. So The aggregate is the parent class, which is over here, and the components are the children class. So this is going to be like the parent class, and then these are the children, if you want to think of it that way. Okay? So if you want to represent a system and you have different subsystems, and there is this aggregation relationship, this is how you're going to do it. This is what you're going to use. Okay? So if anything we draw using UML has a meaning. And we all have to abide by that meaning because this is a standard. Okay? If I send this picture to somebody in the UK, they will interpret it the same way as I do because it's the same language. Unified modeling language, which is graphical language, in other words. Another concept is generalization, which I mentioned earlier, where we are going to have a parent or a superclass, and then we're going to specialize it into a subclass or special class. So here's an example of generalization where I can have a button. This is in, if you are creating a user interface, that user interface can have a button that you can click, okay, on your computer. And then we can have a class called button, but this is a parent class. This is a general class. Then we can have a special case. So we can specialize this into, or generalize it into another type of button called a cancel button, and then another one which is called zone button. Okay, but they're all type button. Okay, but these are just generalizations. So the children classes inherit the attributes and the operations of the parent class. Okay, why do we have to do this? Well, if I define attributes here, I define methods here, I don't need to define them here again because this is going to take on the attributes of its parent. Okay? And so I don't have to do it again. So generalization simplifies the model by eliminating redundancy. We don't have to repeat things over and over. And this is a very powerful concept in software engineering, generalization. So the UML graphical representation of a generalization is going to be a hollow triangle like this one. Okay. Again, it's very important to keep that in mind. Why we have to do this generalization. Again, we are trying to eliminate redundancy in our representation. So class diagrams represent the structure of the system, and class diagrams are used during requirements analysis to model problem domain concepts. We use class diagrams during system design to model subsystems and interfaces. During object-oriented design to model classes, we use class diagrams. So here's another example of a class diagram. So again, I'm going back to bank account. Bank account, according to the representation here, you can say that this is a superclass. Okay, so I have a superclass up here, and then I'm basically going to generalize it into some kind of specialized or special class. Okay, so I have a bank account which can have a name, owner, the balance. It can perform deposit, withdrawal, but I can also have a special type of bank account which I can generalize from here, which is checking account. So checking account has attributes, for example, insufficient funds fee. It can also have two methods, process check, it can process checks, and it can also withdraw. But because checking account is a generalization of bank account, it also has these attributes here and these methods here. Similarly, the savings account is just a special type of bank account. So savings account, unlike checking account, has annual interest rate. Well, it's a savings account. It's going to earn some interest, unlike the checking account. It also has deposit monthly interest as a method, and it also has withdraw the amount. But it also has everything up here because it's just a special class of this superclass. Question, Justin?
It inherits all the same attributes. Does it inherit all the same operations?
Yes.
So in that case, then why does the bank account have to withdraw? Why do you have to repeat withdrawal on both of the bottom ones?
In this case, you don't actually have to, you don't have to show this here. Even though it is shown here, you don't necessarily have to show the withdrawal. Okay, you don't need to show this one. This is just for illustration that this one is going to show up here. Same thing with deposit is going to show up here. But you don't need to actually show them as shown in this particular figure. So you can actually delete this withdrawal, and the savings account is going to actually see these two methods. Good point. Any other questions? You only define methods here which are going to be unique to this particular class, special class. Okay? Okay, so another example of a class diagram. Again, this one actually shows you the different associations, the different relationships. Okay, so I need to move a little bit faster. So the company consists of, I'm just reading the diagram here. So this company consists of, this is an aggregation, a department and an office. Okay, you can have more than one department. That's what this says. One-to-many relationship. I can have more than one office. And then under office, I have headquarters, which is just a special type of office. Over here, department, I have this association. Each department is going to have a person, okay, who can be a member or can be a manager. And then over here, we have a person with different attributes, and there's dependency here. So for each person, there's dependency on contact information. There's also dependency on personnel record. Okay. So this, again, by reading the diagram, you can see a lot of different types of associations or relationships among the classes. Okay. So use case diagrams. We went through use case diagrams before. The key thing here is system functionality. And we use use case diagrams during requirements elicitation. That's when we're trying to discover requirements to represent external behavior. Easy for user to understand. We can have different use cases and show the customer. The customer can say, no, this is not what I want. Then you can go through a process of building use case diagrams. So we went through this, so I'm going to go through this quickly. So we're going to have an actor. We're going to have a use case. And then the actors are going to represent the object, which can be the user, or it can be an external system or physical environment. Let me go to an example of a use case diagram. Here's an example of a use case diagram where we have a user and we have a cellular network. So the user can place a phone call. A phone call is a use case. Place phone call is a use case. Then the user can also receive a phone call, so that's a use case. And then we have a user can use a scheduler on their cell phone. Okay. So again, this use case shows you what kind of functions this cell phone can perform between user and cellular network. Okay. And here's another one. Again, you can go through those slides on your own. These are pretty straightforward. Then we can also have extended relationship, and I think I showed an example before. In this case, when we talk about extended relationship, we're talking about having this kind of diagrams which shows dependency. So I can have a use case between a student and registration clerk. This is for a university registration system. A student can register for classes, okay? But there can also be special cases where a student has to register for a special class. Okay, if you have to register for a special class, for example, this course is for graduate students, but I also allow senior students to take the course. So for them to register for the course, they are not going to use this use case. Okay, the system is going to detect that they are undergraduate. It's going to tell them that you have to register through this use case, which means they have to come and talk to me. Okay, so this is a registration for special class. So they have to contact the instructor for approval. Okay, obviously the instructor is going to look at their GPA, their performance, and make a decision. Okay, so this is so with use cases we can also have extended relationships. Okay, so that's our use case diagrams. Sequence diagrams, again, we went through these. We went through an example. Here is another example. And Eduardo may go through some other examples as well, which shows sequence diagrams. It's going to basically show the behavior of a system under a certain scenario or certain conditions. Okay. Another sequence diagram. Again, just remember that with sequence diagrams, the time is going to flow downward. Okay. So, for example, you have a teacher. They log in to a web interface, and it takes a few seconds or a few amount of time over here. Then the system is going to validate them, basically checking the database and send back a message to the web interface. And then that's going to take some time to process. And then the web interface is going to take some time as well before responding back to the teacher with successive log on, or maybe unsuccessful, and so on and so forth. So the behavior will continue going down this way. State transition diagrams, again, you've done several of these, but when we represent state chart diagrams or state machine diagrams in UML, we are basically going to show, we are going to include this thing we haven't seen before, which is just a solid dot. It means that when you initialize the system, okay, it's going to go in this particular state. So this one shows initialization. Okay, so when you initialize your system, it goes into idle state. Then from there, it can now transition to what the different states based on what's happening. Okay. Again, we've done this systems models and how to represent the state transition diagrams. We can also do that in UML. State charts, continuation here is another example. So we have initialization here. You initialize your system, and here this is where you may end or terminate your system. Okay, so you start here, open incident, and then you do stuff, and then eventually you may have to terminate your system. Again, you turn your system on, you're going to start right here. Activity diagrams. The activity diagrams show the flow control within a system. And an activity diagram is actually a special case of the state transition diagram. In this case, the states are basically going to be activities. Okay, instead of looking at the state of a system, you're going to be looking at activities, and then you're going to show the flow of activity within a system. Whenever you have an option to do different things, you're going to have this diamond shape. Okay, then it means, for example, here you start by identifying customer. Then from here, you can either go here or you can go here. So if authentication fails, then you can come here. If a customer is identified, then you come down here. You take the reservation wish, you check available space, then you come to another decision point. Okay, you can either go here if you want to cancel, or if it's okay, you can go and do the reservation. Okay, so this is an example of an activity diagram. Okay? So it's a special case of the state chart, but you are no longer looking at the states, you are looking at activities. So in summary, UML provides a wide variety of notations for representing many aspects of system development. It's a very powerful but complex language. Nevertheless, it can be misused to generate unreadable models. Here we have just looked at some of the few diagrams that are necessary for what we are doing. Another thing I should mention here is that remember, the UML was designed for software. So as for systems representation, it lacks certain things. For example, in our systems development process, we look at the system from top down. Okay, so we look at the system, then subsystems, and so on, and then we do iterations. UML in object-oriented analysis focuses more on the bottom-up approach. Okay, so when we use UML, we have to keep that in mind. We are using it for the sake of representing the different aspects or different views of the system. And that's where IDEF methods are more powerful in terms of representing systems. Okay? Okay, so I'm going to have Eduardo take over, and he is going to show us how to create diagrams, UML diagrams using IBM Rational Data Modeler. We have two types of software. This is one of them. The other one we have is IBM Systems Developer. Okay, so both software should be installed on your machine. So I would ask you to sit in front of a computer and log in, and he's gonna give you hands-on instructions, so that by the next 25 minutes you should be able to create something before we leave. And then you're gonna do it on your own for your project. If you have questions, you can let Eduardo know. For the distance learning students, you can do a remote desktop connection, and you should be able to access the IBM software on any of our machines. If you have any issues, send me an email, and we're going to resolve that as soon as possible. Okay? Ready? Okay, so make sure you sit in front of a computer and log in so we can just follow along.
So make sure that at least one of the members of your team has a computer. So the last 4 slides of this lecture provides the instructions of how to get to the window you need to develop your diagrams. For example, for the use case diagram, if you go to slide 41, you will see the instructions, the detailed instructions to get to the window you need to create this diagram. And same thing for the other ones. So let's get started. Let's go to the Start button here and go to the Programs folder and find the IBM Rational folder. Click on that and select the IBM Rational Road Professional Data option. So this is the first window you will see. You don't need that window. You can click Cancel. In this side of the main window, you have a menu or a folder options. You have 3 different folders. If you want to access the class diagram option, you click inside the logical view folder and double click on main, and that's the window we already have. In this toolbar you will see all the components you need to create your class diagram. So let's start with that. What I'm going to do is I'm going to use the examples that Dr. Entaimo used for the lecture. So for the class diagram, I'm going to show you how to build this example. So the first thing I would recommend you to do is to insert all the classes you need for your model. So let's say first one in this example is company. So you go here, you click in the class button, then drag this cross here inside the window and click again, and then you'll have a new class. Go. So you can insert a name. So the second class we need is department. Go ahead. Another one is office. The next one is person. And as you can see, each class that you add is saved by the software. And you can see that here. You start seeing the list of classes in this side of the window. And just let me add one more, just for the purpose of representation. This one is the headquarters. So now that you have your classes, the next thing you need to do is to add any attributes or methods for each one of your classes. In this example, for the person, we have 3 different attributes and 4 methods. I'm going to show you how to add one attribute. Click on that class, right-click, and here you have an option to add a new attribute. So click on that and just type name. And you'll see that the attribute shows up on the second row of the class diagram. Then if you need to add the method, just do the same thing, right-click, and select New Operation. And let's just choose one, get photo. So you do the same thing if you need to add more than one. Now, the other thing you need is to define the associations between the classes. So in this example, we have an aggregation from the company class to the department and the office. So what you're going to do is select this arrow here, the unidirectional association. Click on that. Click in the department class and scroll to the, just select the department and then go to company and release the button. And you will see that now you have a unidirectional association between these two classes. What you want to do now is to change the type of association. So if you double click on that arrow and go to the Role A Detail tab, if you uncheck this Navigate and click Apply, you will see that the arrow disappears. Now, what you want to do now is to select the right association, and in this case is Aggregate. So check Aggregate and click Apply, and you will see the diamond is going to show up. Now, in this window, you have several options. The one I selected was Role A Detail. For any case you need to add another detail to this association, you can also select Role B Detail, and you can edit the other side of the association. For example, if I click on Navigate and click Apply, you will see that the other side of the association will be edited. But in this case, you don't need it, so uncheck that. Basically, you will be using these two tabs to edit your associations. Click OK. Do the same thing for the office company associations, and click on unidirectional association. Go to Office, then to Company. Double click. Go to Role A. Uncheck Navigate and click Aggregate. Questions? Okay. Now, if you're going to add multiplicity, right-click again on the association you want to edit. Go to the Role A Detail tab again, and here you have an option to select the type of multiplicity you want to use. In this case, we have a 1. Click Apply, and the 1 is going to show up. If you want to add the multiplicity to the other side of the association, go to the Role B Detail. And in this case, we have 1 to n, or 1 to multiple. Let's choose this one. Click OK. Okay. Now, Another type of association is the one that occurs between the department and the office. So this is a non-directional association, so we need to delete the arrow. So in this case, we go to row A and uncheck that navigate option and click apply. Okay? And the last association that is different in this diagram is the generalization association that occurs between the office and the headquarters. So you do the same thing, follow the same process. You select this arrow. Then connect the office with the headquarters and edit this association using this tab. So in this case, no, I'm sorry. In this case, you don't need to use the association. You just select the option generalization here, which is a different option that is on the toolbar. So please go back, delete that association, and select generalization from the toolbar. And then connect those two classes. Okay? So basically, those are the tools that you need to build your class diagram using IBM Rational Rows. Questions? Now, we're going to transition to the use case diagram. And we are going to use this example, the cellular phone example. So to get to the use case diagram window, you go to the first folder, use case view, here on your left, and click on the main option. Now you'll see that you have a toolbar with the items of the use case diagram. And basically, you follow the same approach. You select the actors you need for this diagram. In this case, we have a user. So type user. And we have a cellular network. So that's another actor. And now you're going to define the cases using this use case button here. Select that and insert. In this case, we have 3 different cases. So let's add those 3. And let's edit the names. So in this case, it's place phone call, receive phone call, and use scheduler. And now we proceed to define the associations between the actors and the use cases. Again, you select this unidirectional association, select the user and the corresponding use case. If you want to define a unidirectional association, you don't have to do anything else. But in this case, it's a non-directional association. So we need to edit this association. So click on the arrow and go to the Role A Detail tab and uncheck the Navigate option. You do the same thing for the other cases. Questions? You can save this worksheet in your directory, and it will save all the diagrams that you have constructed under the same file. So let's just listen, 640. So when you open this file, you will have all the diagrams in the same file. So now let's transition to the next diagram, which is the sequence diagram. And let's build this one, which is the teacher web interface and database sequence diagram. So to get to the sequence diagram window, you have to go to the Browse option here at the top. So select Browse, and then select Interaction Diagram. Here you want to create a new diagram, so click OK. And you need to provide the name for this diagram, so let's call it just web. And the diagram type is already selected, which is the sequence diagram. So click OK. And now you'll see the toolbar that you need to create your sequence diagram. So let's follow this example we have here. The first thing we need is to define the objects. In this diagram, we have a teacher, a web interface, and a database. So go to the toolbar and select Object. The first object is the teacher. Add another object. This one is called web interface. And the last one is the database. Now, what we're going to do is to define the interaction between the objects. So in this example, we have a login interaction. So to define that interaction, go to Object Message here in the toolbar and select that arrow. Then go to the first object, which is the teacher. Select the timeline from the teacher to the web interface. and you will see that the arrow is created with some time. Now we need to name this interaction login teacher. From here, we have another interaction that goes from the web interface to the database. So select the same arrow and select the timeline from the web interface to the database. And let's name this as validate user. Okay. I don't know what happened here. Okay. So now, after the user, this message is passed to the database, we have to return a message to the web interface and also from the web interface to the teacher. And we have a different type of arrow for return a message, which is this one. Go to the toolbar and select the arrow that said return message. And that message is going to go from the database to the web interface. Something that you have to be aware of is that this sequence diagram is going to start creating these times between the actions. So as you can see, there's some time between login teacher to validate user, and then from validate users to returning the message. Now, when you return the message, this is a separate action, and you want to have a separation between these two time windows. So what you do is you click on that rectangle and you try to decrease the size of that rectangle, and you will see that at some point it is separated now. This is kind of tricky because now the separation went on both sides. Let's see if I can get these two things to be together. Let me see if I can. Delete this message. Well, I just wanted you to notice that there's still timelines between the passage of messages. So be aware of these times windows, okay? So there you go. So there's a time between validating the user and then to return the message. Now from here, you're going to return the message also from the web interface to the teacher. So you select the same arrow and then go back. Now, let me just complete the diagram. Now you have another interaction between the teacher and the web interface. So select object message from here to the web interface and name the interaction as look up student, and so on. So basically, you add those objects, and then you start defining those interactions. You have to be aware of the times, okay? On the time, yes, 2 minutes. on the times between those interactions. Now, finally, the last diagram is the state transition or state chart diagram. To get to that diagram, again, you go to Browse, select State Machine Diagram. You're going to create a new state diagram, so click OK, and name that diagram. In this case, you need to switch from activity to a state chart, so select State Chart, and then click OK. And here you'll, yes? I can show you later. Let me just finish this. If you want to delete something, let me see. Okay. Just to generate the state transition diagram, again, now you have the toolbar that you need for that, and you can add the states. You just follow the same approach. Add the states you need, and you use the state transition to indicate the transitions between states. I think this one is pretty straightforward. If you want to name that transition, you can name it clicking on the arrow. Now, if you want to identify your initial state, you go here and select Start State, and then you add an arrow that will identify this new state number 2 as your initial state. And also, if you want to add nodes, you can always select this icon here that says node, and you can type nodes for whatever you need for your diagram. Okay? And answer your question. So, the interaction diagram. I mean, if you select your arrow and click delete, it should disappear. But that's basically what you need to do. Just select and delete. Okay? And again, the instructions, detailed instructions to get to the windows, and the instructions to construct the diagrams are provided in the lecture, at the end of the lecture.
Okay, so thanks, Eduardo. I hope that's going to give you a jump start for creating UML documents. And so we're going to stop here. I should also remind you, make sure you save your work often when you're creating these diagrams. Don't come at the last minute and say you lost your work because there was a power failure or something. Okay, have a good weekend.